So today we need to talk about something called an inverse function. What do you think just think of what do you think an inverse function does? Yeah. If you do something, the inverse will what do you think it will do with it? Not quite the opposite, but just like it will undo it. Okay. So suppose there's a function that every morning takes you from your home to Woodward Academy. What do you think the inverse function would do? It would take you from Woodward back to home. Okay, so it undoes everything that you've done. Okay, so for example, if I started with an x, if I were to add 3 to x, I get x plus 3. What would I need to do to undo what I just did? Yeah, I would need to subtract 3. Okay, so to undo that operation, you would need to subtract 3. So what happens is, if I take x, what happens when I add 3 and subtract 3? Where do I end up? No. X. I have x. I add 3 and then I subtract 3. I end up where? Back where you started. So you leave your home in the morning, you get to Woodward. You leave Woodward, you get back where? Home, right where you started. So an inverse function will undo whatever has been done. Okay? So what are inverse? You know these without thinking about them. What is the inverse of multiplying something? Yeah. The inverse operation would be to divide. The inverse of squaring would be to do what? Yeah, the square root. The inverse of adding, we know that one is subtracting. The inverse of subtracting, see, this is like middle school stuff this morning. The inverse of dividing would be to multiply. What's the inverse of the cube root? The invert of the cube root is to cube, okay, to cube something. Okay, so the inverse of the fourth root is the inverse of taking something to the fourth power, okay? So these are inverse operations. So let's look at the graph of two functions, x plus 3 and x minus 3. So this graph right here, this is f of x is x plus 3 and g of x is x minus 3. These are the graphs of what? What do it look like when I graph them? Horses, dogs, cats, what are they going to look like? Graph of a what? Line. There we go. Come on. This is stuff that's in there. You know this. The graph of a line. So if I plug in a negative 2, what is negative 2 plus 3? 1. What is negative 1 plus 3? 2. What is 0 plus 3? What is 1 plus 3? And what is 2 plus 3? Okay. So those are all points on x plus 3. So negative 2, 1. Negative 1, 2. 0, 3. 1, 4. And 2, 5. Okay. So that's that first line. So let's draw that line real quick. Okay, that should be about close enough for me, because this is the line x plus 3. Okay. Now let's graph the line x minus 3. So what is 1 minus 3? Negative 2. 2 minus 3. Negative 1. 3 minus 3. 0. 4 minus 3. 1. And 5 minus 3. 2. So 1 negative 2 is right here. And 2 negative 1 is right here. 3, 0. 4, 1. And 5, 2. Okay. So if I graph that line, it goes from this point let me see if I can make that a little bit more accurate there. Okay, not quite, but we'll see what we can get. There we go. Okay, I'm still being a little bit picky about this line, so bear with me. Something like that. Okay. We'll let that be close enough for our work. Okay. So this is the line x plus 3 and the line x minus 3. Are they symmetrical? Is there some kind of symmetry going on here? They're parallel. Okay. We talked about what does it mean to be symmetrical about the y-axis. That was what we did when we talked about what? What was if a function is parallel about the y-axis, we say it's what? Starts with the word e. Not equal. Even. There we go. Even functions. Okay. These lines are parallel, but they're symmetrical. If I were to draw a line that went from here to here, straight through the axis, the lines are parallel about that line. Okay. So this is the line, this green line here, that's the line y equal x. Okay. These two functions are symmetrical about that line. So if the green line was a mirror, I see the same thing on either side of the line. Okay. Graphically, that's what it means to have an inverse function. Is that if I draw this line y equal x, which is the diagonal, what I see on both sides are mirror images of each other. Now it's a little bit harder to see. We were good when this was our mirror. Remember when the vertical axis was our mirror, we say, okay, it looks the same on either side. Here you can just sort of tilt your head to the right. If you had a line going through there, if you've got symmetry on both sides, that means these are inverse functions of each other. Let's look at a couple things here while we're looking at this. What do you notice about the points here? Okay. Look at this function has -2, 1 as a point. What does the other one have? 1, -2. What about this one? -1, 2. This has 2, -1. 0, 3. This one has. So it's almost like what? They're switching points. Okay. So what's happening is, if 0 is what takes you from home to Woodward, then how do you get from Woodward to home? You have to go from where? 3. You have to go backwards. Okay. So if I go from 0 to 3, the only way I can get back home is I got to figure out how to go from 3 to 0. So the inverse just changes the role of x and y. So let's take a little bit of a further look at this. Let's look at x cubed and the cube root of x. So this is x cubed, and this is the cube root of x. Okay. What happens when you cube a -2? -2 times -2 times -2. -8. Okay. Cubing a -1. Okay. Cubing 0 is what? 0. 1 cubed and 2 cubed. This is one of our parent functions. You know what x cubed looks like. Okay. So x cubed, it goes through these points right here. So we know that x cubed looks something like this. That's x cubed. Okay. Now, cube root of x. What's the cube root of -8? -2. Cube root of -1. -1. Cube root of 0. Cube root of 1. Cube root of 8. So remember, x to the 1/3 was another one of our parent functions. It goes through -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So remember what this function did was something like this. Let me do that a little bit better. Something like this. Okay. Now, if I were to draw a line straight through the middle right here, do they look like they're symmetrical? Well, if I drew better. If I drew a line straight through here, yeah, they should be. So it has to be symmetrical about the line that goes straight through here. So they do look like mirror images on either side of that line. So these are inverses. Okay. The other way to tell is -2, -8. I better see -8, -2 over here. -1, -1, -1, -1. 2, 8, and 8, 2. So what happens, x and y just switch roles, making these inverse functions of each other. The red line is just the line y equal x. And if these two functions are inverses of each other, I can tilt my head to the right and that red line should be the mirror, okay? And these things look identical, okay? So what we notice is that, what do you notice about the XY points to graph F versus to graph G? They just basically switch roles, okay? So we know that if, XY on the graph of F becomes YX on the graph of G. All that happens is if these two functions are inverses, their X and Y values just change roles, okay? Now what the notation we're going to use for an inverse is this F -1. This is not a negative exponent. So what we'll say here is that we read this like F1 of X, that means the inverse of F, okay? And likewise, if you ever see something, like that means the inverse of G, okay? So when you see that -1 exponent, it doesn't mean negative exponents. Math is famous for using the same thing, and it means different things at different times, okay? Just like a language, context is key. So let's graph the inverse. Yeah. What's the question? Okay. So let's figure out, now that was a little bit more involved than you're going to have to do every time, but if I give you this graph, I want to know the inverse of this graph, okay? So what's the big thing, the inverse? What happens to my points? They do what? They flip-flop, okay? So what is this point right here? I can't read it, but you can. -8, 0? Okay, this is the point, -8, 0. What is this point up here? Right here. -3, 5. Okay, okay. And then what is this point up here? What, -3, 8? And then this point over here is what, 1, 4? Okay. So all I did was just identify those points, okay? Now, if I'm going to graph the inverse, what points do I need? So corresponding to this -8, 0, what point needs to be on the inverse? 0, if this is -8, 0, the inverse is going to have 0, -8. So 0, -8 is right here, okay? That point has to be on the inverse, and it looks like it's a closed circle. And then if I've got an open circle at -3, 5, where would that be on the inverse? 5, -3. So 5, -3 is going to be an open circle. Okay, and then what will I do with those two dots? This is where you play connect the dots, okay? And then if -3, 8 is on this function, what point is on the inverse? 8, -3. So 8, -3 puts me about where I just wrote that a moment ago. Let me. So this point was what, 5, -3? Was that point? Yeah. So 8, -3 is right here. And then if 1, 4 is on the graph, what else needs to be there? 4, 1 has to be on the graph. And we go there. You don't have to always label these points, but that's drawing the inverse, okay? Now, if you don't have to do it, but if I turn my head sideways, it is symmetrical about the line that would dissect those quadrants. So that's how you draw the inverse. You basically just identify the points that you know, change the role of X and Y, and then you're able to graph it. Okay, pretty straightforward. Now, what's a little bit different is how do I find the inverse if I don't have the graph? Okay, so you still have to just rely on the basic definition that the inverse, all it does is it does what? It switches what? The roles of X and Y. Okay, so let's rewrite this. Let's write this as Y equal X cubed plus 1. That's my function. Okay, so Y is equal to X cubed plus 1. Okay, now what would happen if X and Y switched roles? What would it look like? X equal Y cubed plus 1. That's what happens when I switch x and y. And then, whenever you see something like this, what am I usually wanting you to solve for? An equation like this. Usually want to solve for y. So I need to solve this equation for y. So what's the first step in getting this y by itself? What will I do? Yeah, so if I've got x equal y cubed plus 1, the first thing I'm going to do is subtract 1 from both sides. So I get x minus 1 equal y cubed. Now, I'm solving for y cubed. What do I need to take on both sides? The cube root of both sides. So now I need to take the cube root of both sides. So I get the cube root of x minus 1 equal the cube root of y cubed. What's the cube root of y cubed? That's y. That's doing something and undoing it. So this tells me that y is equal to what? Yeah, the cube root of x minus 1. Now the way we write this in function notation is I'm going to write the inverse. So f inverse of x. So f inverse of x is the cube root of x minus 1. So I started out with f is equal to the x cubed plus 1, and I end up with f inverse is the cube root of x minus 1. Now, let's talk through this. In English, what is happening? Just tell me through. In English words, what is happening here? You're doing what? You start with x, and what are you doing? You cube x, and you what? Add 1. So in English, this is to cube x and add 1. Okay? That's what the function f does. Okay? So I cube x and add 1. Okay? Now, let's talk about the next one. When I get down to this one right here, if I start with x, what is happening to x? Here's x. Read this like it's an English sentence. I start here. What am I doing? I'm subtracting 1, and then I'm doing what? Cube root. So this one, I am subtracting 1 and cube root. Now, you don't have to do this for all of your answers, but what I'm trying to illustrate here is if you cube something and add 1, okay, that takes me from here to here. How do I undo what I did? To undo the adding 1, you would do what? Subtract 1. To undo the cubing, you would do what? Cube root. So what I did down here was subtract 1 and cube root. So the inverse function just, like I said, when you come from home to Woodward, you backtrack. You start at Woodward and you're taking the opposite direction of everything that you did earlier in that morning. Okay? So that's what the inverse function does. So what is the domain of our original function? Our original function x is right here. Do I see any square roots or any fractions? No? Yeah, so what's the domain of f? Yeah, negative infinity to infinity. And then here's my inverse. Do I see any square roots or fractions? Answer is no. I don't see square roots. I see cube roots. I don't have any restrictions on cube roots. I can take cube roots of positives and negative numbers. So what's the domain of this guy? Yeah, negative infinity to infinity. Okay. So neither of these had any restrictions on it. Okay. Now that's probably the more involved part of this section, but we'll do a couple more examples of this. Okay. Let's start with this function. F of x is 5 over x minus 2. I want to find its inverse. So the first thing I do, I write it as y equal 5 over x minus 2. The whole big premise of an inverse is that what happens to make an inverse? X and y switch roles. So let's switch x and y. So x equal 5 over y minus 2. Now, in order to find the inverse, I'm going to have to solve that equation for which variable? Y. So what I'm going to do is I'm going to say x equal 5 over y minus 2. What is it you don't like working with in equations? Fractions. I can make this fraction go away if I multiply both sides by what? Y minus 2. Okay. So what do I get? I get x times y minus 2 is equal to what? 5. Okay. If I'm solving this thing for y, what do I do next? Divide both sides by what? X. So that gives me what? Y minus 2 is equal to 5 over x. What's the next thing I do? Add 2 to both sides. So y equal 5 over x plus 2. So my inverse function, f inverse of x, is 5 over x plus 2. Okay, so what is the domain of my original function? Okay, my original function has a problem somewhere. Yeah, it's got a fraction, so it does not exist at what number? This original function. At the x equal 2 is my problem. So what's the domain of that original function? To 2 to infinity, okay? So the original function is negative infinity to 2 to infinity, okay? Because if x were equal to 2, this would be 0, okay? So this cannot be 0. So this original function here has a domain from negative infinity to 2 and 2 to infinity. Okay. Now look at my inverse function. It's okay at 2. It has a problem where? It has a problem when x is what? 0. So x can be every number except 0. So what's the domain of the inverse? Negative infinity to 0. 0 to infinity. Okay, let me pull example here. What follows? So what we've done so far, if I give you a graph, you should be able to graphically give me its inverse. Okay, you use this notation, that superscript. Yes, sure. Do you need help? Or are you good? Or you? Okay. When you use a superscript, that's after the -1. That means inverse. In order to algebraically find the inverse, remember we just switch x and y, and then solve for y. Okay. So let's talk about things that are functions or not. We'll talk a little bit about this more in subsequent lessons, but you should have learned something that to tell if something is a function, there's something called a vertical line test. Okay. So if I look at this graph, I can draw vertical lines and it hits my graph more than one place. Okay. So it tells me this is not a function. Okay. So it's not a function because I just picked a point here. You've got 5, 3, and 5, -3. So you're plugging in a 5 and you're getting 2 different values back. So this is not a function. This is going to have implications when we do the inverse later. Okay. So we'll talk a little bit more about this later, but you should have seen this at some point leading up here. When you see a graph, if you can draw a vertical line, touches more than one place, this is not the graph of a function. Okay. So let's do another example here, finding an inverse. Okay. So what's the first step that I do? I have to write it as what? Y equals, so I replace that as, so y is equal to 1 over x plus 1. Next step in finding the inverse is I have to do what? Swap the role of x and y. So you just rewrite this as x equal 1 over y plus 1. Those parts are pretty easy. This is where a little bit of the heavy lifting comes in. Now I need to solve that equation for what? Y. So what's my first step? Subtract 1 from both sides. So x minus 1 equal 1 over y. Okay. Again, what do I not like about that problem? The fraction. I can make that fraction go away by multiplying both sides of this equation by what? By y. Okay. So then I get y times x minus 1 is equal to what? 1. How do I solve that for y? Divide both sides by what? Yeah, divide both sides by x minus 1. So what does that give me? Yeah, 1 over x minus 1. Okay. So this tells me that write it in inverse notation. F inverse of x is 1 over x minus 1. Okay. And then the other thing that we did is graphing an inverse. Okay. So to graph the inverse of this guy, I just need to figure out what is this purple point right here? What is that point? It's what, negative 3, 2? So what point do I need to go find? 2, negative 3. So that's the corresponding point there. Okay. What's this blue point? Negative 4, 1. What point do I need to go find? Yeah, 1, negative 4, which is right there. And then the green point is what? Negative 5, 0. Means I need to go find what point? 0, negative 5. Okay. And so I've got to make it look. And here, just to be sure, let's look at this point way up here. This is like what? Negative 2, 10 way up here. Negative 2, 10, I should be looking at what? 10, negative 2, somewhere out there. And if this point is like negative 6, negative 10, I need to be finding like negative 10, negative 6, so somewhere out here. So what you see this graph doing is something like this. With that. And what you should always do, once you look at it, if you were to tilt your head sideways, it is symmetrical. If you drew a line from here to here, it should look symmetrical about that line. How what? This line? Well, you take the opposite of each of these points. This point right here is about, that's look, negative 210. Well, it's somewhere up here in the neighborhood of negative 210. So I've got to go head in the direction of 10, negative 2. Okay. This point down here is somewhere around negative 6, negative 10. So somewhere around negative 10, negative 6, I've got to land. Okay. So even though you don't just limit yourself to these 3 points, where is this thing headed? Okay. And then figuring out where that needs to go. And like I said, if you were to draw this line right here, what you're seeing is symmetrical. If you drew this thing headed up here, it's not symmetrical about that green line. Okay? Is that the end of this section? That is it. Okay.